Okay, so this video refers to Lecture 4 on moments, and specifically it's an introduction to the cross product. So we looked in the introductory video to moments on how you could find a moment about a point as being a force times a distance. If we scale this up to 3 dimensions, that becomes more difficult. However, we can find the cross product of 2 vector quantities to find the moment that results from them. So a vector force and a vector displacement. This will also work in 2 dimensions, and 2D is a simpler, obviously just a simpler version of it. So the cross product of 2 vectors will result in a 3rd vector. And unlike the dot product, the cross product, it does matter which way around you're crossing them, if you're crossing A with B or B with A. And the magnitude and the direction of that vector you can write as AB sine theta, and there'll be a unit vector associated with that. So, for instance, this is slide 9 of the lecture. You can see you've got a vector A and a vector B, and in the diagram someone is right hand. It does have to be your right hand, so it helps if you know your left from your right. For those of you who can see, I'm holding my right hand up now. That's just me though, because I'm the only one in the room. So as I hold my right hand and curl my fingers from A to B, because I'm crossing A with B, then my fingers will curl along the direction of that curved arrow. That marks theta, and my thumb marks the direction of the unit vector C, to the direction of the resultant vector from that cross product. And there are a couple of ways of solving that. A couple of ways of learning how to solve that, and I'll show you both of them. The technique we'll use primarily will be with matrices, which you may have met in your maths module, but I'll show you another way as well, because it will come up sometimes in statics, but it also comes up in dynamics. So if you have your I vector and your J vector and your K vector, I'll draw these. If I cross an I with a J, I get a K. So plus. So this is all positive. Let me go to a different colour. If I cross the other way, negative. So for instance, an I crossed with a J becomes a K vector. So that's just what we were saying. If your A, I've missed some of the lines here, apologies. If your A vector and your B vector were crossed, they become that unit vector C would be in the 3rd dimension, so it would be a K. So if I cross an I with a J, let me see if I can, there we go. Whoops. That didn't do quite what I expected it to do. If I cross an I with a J, I come out with a K, and it's positive because I've followed the positive direction around the circle. If I cross a K with a J, back to a pen, following it this way around the circle, I get to I, and because I've taken the negative direction around the circle, the green direction, it becomes a minus I. So it does matter which order you write your cross in, whether you're going from K to J or J to K. And that kind of makes sense, because if we imagine this diagram again, if I was crossing from B to A, my arrow, this curved arrow, would be the other way round. Still using my right hand, the thumb would be pointing downwards, so that would be negative. So that's one method of looking at the cross product. The other method is using matrices. So if you refer to slide 11 in the lecture notes, then it shows you the simple way of finding a determinant for used to do the cross product. However, I'm going to move on to the moment crossed with the force. The position crossed with the force. So I'm looking now at slide 13, if you wanted to follow in there, just so we go straight into a specific example. So let's turn the pointer off. So we know that our moment about a position O is our displacement crossed with our force vector. So we could write that in terms of I, J and K, and we could have a position Rx, Ry, Rz, and we could have a force Fx, Fy and Fz. And our moment is then going to be, I don't know how to do this for the best, it's going to be in the I direction, it's going to be Ry crossed with Fz times Fz minus Rz times Fy. So Ry Fz minus Rz Fy I. In the J direction, it's going to be Rx Fz minus Rz Fx. So Rx Fz minus Rz Fx J. Should probably have done the brackets around that one. Now what you get always for your J direction is you put a minus on the front of that, only for the J direction. And then in our K direction we're going to have Rx Fy minus Ry Fx. So Rx Fy minus Ry Fx in the K direction. And that'll be a plus again. So as you can see, we're still going to have an I, J and K component in the solution. So we'll still have a vector answer. That's why we've got the moment as a vector. So that was a very quick introduction to the cross product and using it to find particularly moments. In the next video we'll look at some examples using the scalar and then the vector methods of solving these questions.